So welcome everybody to this week's version of Statistics Can Be Fun. Last week we talked about the very first stages of what to do with your data, how to get it into SPSS, and the data cleaning stage. So we talked about what we need to do to ensure that our data is ready to be analysed. We talked about how to transform questions in a scale into a total score for your participants. We also talked about how to reverse code any questions in a scale that are reversed. And we talked about generating variables. And then we did a little bit of a test on continuous descriptives. And we found some mistakes in my data set, which was really cool because we're actually, this data set that I am using to do the tutorials is actually a real life data set that we are using, my honours student, myself and my supervisor are using at the moment to test a survey that we did in July on diet and depression in vegans, vegetarians and omnivores. So we found this mistake and we'll talk about that as we go through the data now. So today we're going to be looking at the next step after data cleaning. So data cleaning is always the longest step of any data analysis, making sure that our data is in the right format to be analysed. And it is also one of the most important steps because if we miss something in that data cleaning stage, then our results are obviously going to be incorrect. So it's the longest stage and it's the one that you need to pay most attention to. Now, the next stage after we've cleaned our data is we need to look at what our data set looks like. And we're basically looking at the characteristics of our population. So we want to see what type of people are in our data sets, or if you're not doing a project using people, you might be using blood samples, or you might be using something that's not people driven. The population of those are also called a population. So we're looking at our population characteristics, and in a health sense or an education sense, we're looking at what the average kind of age is, what the average gender is, how many people of different cultures and where people are from. And we also want to see kind of on average, or what the data set looks like on our intervention variable, which in the data sets that we're looking at is diet, and on our outcome variable, which is in these data sets that we're looking at will always be depression. So that's the next stage, descriptive statistics, and that's what we'll be looking at today. But the important part of descriptive statistics, apart from looking at what our data set kind of looks like, what our population looks like, it's also going to tell us which variables are significant and need to be put into our model for our data analysis. So data cleaning is our first stage, and then model building and descriptive statistics are our second stage, and that's what we are looking at today. Now, does anyone have any questions before we get started on the data set?
Megan?
Yes.
Could you make sure that Nicola Fraser doesn't keep on cutting in, because it comes to a blank screen for us then and we can't see what you're doing.
Okay, yep, cool. I'll turn her mic off. There we go. Beautiful. Okay, so I'm going to share the SPSS data now. Now, at any time, if you can't see what I'm doing, let me know. Ooh, what is happening here? Oh, yes. Can everybody see that, or is it like weird black?
Yes, we can see it.
You can see it, but I can't. What is happening? Oh, please forgive me while I try and fix my screen. Yeah. Okay. So last week we looked at a different, it's the same data set, but I just trimmed some variables out of it that we weren't interested in cleaning. So this is the data set, the actual data set that we are using with all of the variables in it. So you see that it's kind of a little bit different from last week. So the variables that we have today and that we are kind of interested in, some of them we won't be looking at, but most of them we will. So we asked, in our survey, we asked about gender, age, We asked height and weight, but we then turned that and transformed that into BMI. And all that meant was what we did last week when we transformed and generated variables for our depression total scores and our diet total scores. We just took height and weight and used the BMI calculation, which is, I think, kilograms divided by, so weight divided by height squared, I believe is the BMI calculation. And we transform that into a variable that can be used. So because this is about diet, BMI is a very important confounding variable. And in depression as well, it is significantly related to depression, as you'll see soon. Then we asked about marital status, education levels, dietary pattern. That's one of our most important ones because that's our grouping variable, omnivore, vegan, and vegetarian. So that's our research question. The research question is, what are the, let me think about the research question. What is the association between dietary patterns and depression in vegans, vegetarians, and omnivores? Do vegans and vegetarians have lesser or more rates of depression? And do their diets influence these mental health symptoms? Then we asked some other questions like, how long have you identified with this dietary pattern for? How many takeaway meals do you eat in a week? How many home cooked meals do you eat in a week? How is your health in comparison to peers of the same age? Then we asked about a heap of supplements, which we haven't used. We asked about sunlight exposure, sleep quality, and physical activity, because these are all confounding variables that could be affecting the symptoms of depression other than diet. So they're very important to be looking at, and we'll look at them today. Then we've got all of our CSD questions, which last week we turned into a total score for each participant. Then we've got the BRUMS, the DAS, which are other measures of depression, which we won't be looking at today. We've got our social connectedness total score, which is another confounding variable that could be influencing depression. And then we've got our dietary screening questions, which we turned into a plant-based index. So any questions in the dietary screening tool, which is a pre-validated scale, that were about fish, meat, eggs, dairy, we reverse scored them and turned them into what we call a plant-based index, so that the dietary screening tool was not disadvantaging the vegans and the vegetarians. But at the same time, we kept the traditional dietary screening tool total with those questions not reversed, so we could compare them and see if there were any differences between the two. So that's where we were up to kind of last week. So that's our full data set. So after cleaning our data set, making it all nice and neat like this, the next thing that we do is our descriptive statistics. And when we're doing our descriptive statistics, we're always thinking about if these variables that we're looking at are significant or not. If they are significant, we would then add them to our model. If they're not significant, then there's no relationship between them and depression, and they cannot be included in any further data analysis. And this is an important stage. Otherwise, if you add too many variables or too many parameters to your data and you do your model, then you will get incorrect or skewed results. So this is our second most important stage. So let's go ahead and do that. I've lost all my, I cannot see my menus at the top. I need to be able to use, oh, they're there, okay.
Megan.
Yes.
Quick question. It's Megan Pedler. Hi, morning. Sorry, I've got my camera because I'm having my breakfast.
No problem.
I just posed a quick question in the chat. You keep referring to a model. Are you referring to a histogram that you generate from your data, or are you referring to something else specifically? I was just wondering.
Great question. Thank you, Megan. So a model, or the model of your analysis, is like, say you are going, your question is you want to find out whether these variables that we're looking at influence the outcome. So in this situation, our variables are diet, sunlight exposure, all those types of things, and our outcome is depression. So when we're building a model, we're just basically trying to find out what variables have a significant relationship with depression so that we can put them into a regression model, or it depends on what your data is. It's basically finding out what variables you can put into your final analysis. That's what the model is. Model building is always putting the significant variables into the final, which ones can be put into the final analysis. And it will depend on what statistical analysis you choose, and that will depend on how your research question is formatted. Did that answer your question, Megan?
No, it didn't, but I'm sure I'll pick it up as we go along. I suppose, is a model a visual thing that we're making, or is it more just a matter of refining what it is that we're going to explore further? Because
yeah, that's exactly what it is.
Regression and correlation and things like that, as far as I know, that's when we get to the inferential statistics rather than the descriptive.
Yeah, that's right.
Okay.
So you run your descriptive...
I'll catch up as we keep going.
Yeah. So you run your descriptive statistics, find out which ones are significant with your outcome variable, and then they are the ones that you can put into your inferential analysis. And then that's just called your inferential model of your analysis of what you are going to explore. But by putting variables in that don't have a significant relationship, then your model's going to be skewed, or the results are not going to be correct. And it'll depend on whether or not you're looking at categorical data or splitting groups or things like that. And we'll go through everything step by step as we go through the weeks. Now, if someone could keep an eye on the chat box, because I can't see it while I'm presenting. If there's any questions in the chat, could someone just...
Question. So are we supposed to copy what you do, or should we watch?
Yeah, it's better to watch for the first time, and then I will provide the data set with the recording, and then you can go back over the recording and follow step by step. The reason that we do that is because it's when you're conducting the analysis yourself, it's better if you can pause me and fast forward me or reverse.
Yeah, that makes sense.
Do you know what I mean? So that if you miss something, you can go back and do it. Whereas if you follow along while I'm doing it now, it's you could get a little bit lost.
Sounds good. Thanks.
Yes. And this gives you a general idea of what is happening, and we'll go through the output and things. Okay, so the first thing that we're going to do is today I'm going to show you two different ways of doing descriptive statistics. The first way is just on general data. So we're going to look at continuous and categorical frequencies. If your question is something like, does diet influence depression? Then in the second half of the tutorial, I'm going to show you how to split your data by groups. So if you've got a categorical question, and my example for this is our vegans, vegetarians, and omnivores group. So if you've got a question like, is there a difference between these groups and diet and depression, then I'm going to show you how to do descriptive statistics on that type of data as well. So the first type will be if you've just got a plain question about predictions and relationships, and the second will be if you need to split them by different groups. Cool. So we'll start with the basic descriptive statistics, and this is something that we all run before any type of data analysis, and it's usually the exact same way for every single inferential analysis that you do down the back end. So these steps are the same for each analysis, no matter what you do. So for our first set of descriptives, we're going to look at continuous data. So we'll go to Analyze, Descriptive Statistics, and Frequencies. Now, can everyone see those boxes when they pop up?
Yes.
Great. Okay, frequencies. Can everyone see this dialog box?
Yep.
Good. Good. Great. Okay, cool. So we're going to always reset because the stuff that's in there was from SPSS remembering what you did last, so we always reset. Now, what we're doing is continuous data. So can anyone tell me from last week what ones of these little pictograms suggest that it is continuous data?
The ruler?
The ruler, excellent. So continuous data is questions that we ask where the answer can lie on a continuum between negative and positive, but it always lies on this continuum like a ruler, whereas categorical data, everything fits into categories. Great, so our continuous data, we're going to have a look at age, BMI. We don't need height and weight because we've transformed them into a BMI variable, which is more interesting. We don't really want to know about takeaway meals. So we're just looking at our data of interest. So sleep quality is one that we're interested in. Physical activity levels is one that we're interested in. Our depression total score. We're not going to worry about the BRUMs and the DAS because they will tell us similar things to the CSD. Our social connectedness score, which is another variable that could be influencing depression. And then finally, our plant-based dietary index and our dietary screening tool, which are the same thing except for the meat, dairy, fish, and eggs questions have been reversed so we don't disadvantage vegans and vegetarians. So we've got all of our continuous variables in our data box. Now with continuous data, we always want to click off the display frequencies table because that will give us too much information that we don't need. Then the statistics that we're looking for, we really want to look at the mean, the standard deviation, the smallest score in the data set and the largest score in the data set, so they're minimum and maximum scores, and probably skew and kurtosis not so much. Skew is important because it will tell you if your data is skewed. I normally look at histograms, but the rule is, we'll need the standard error. Okay, the rule is for skew that skew is evident if skew is 3 times more than the standard error of skew, and I'll show you that in a second. That sounds very complicated. Continuous data are always on histograms, so that's the pictorial form or the figure form, and we want to click the box that says show normal curve on your histogram. And then that's it. Now, can you tell me if you can see the output screen that has come up with our statistics on it? Or?
No,
Nope.
say it, Megan.
Okay, cool. So I'll have to stop share and reshare. It often does that. Now can you see my output?
Yes, we can.
Great, good stuff. So what we can see here is a descriptive statistic box for our continuous data. And it basically tells us the very top column or row is our big N. Can someone tell me from last week what big N stands for?
The number of people in this case.
Great. Yeah. Yes. And then they should all add up to 284 because that's how many we have. Last week, we found out that when we ran our descriptive statistics, our plant-based index and our dietary screening tool had 111 missing data pieces, and we couldn't figure out what was going on. So after the tutorial last week, I went back and had a look at the data, and I figured out that all of the questions that were on meat, eggs, fish, dairy, some of the vegetarians and vegans decided that those questions weren't relevant to them, and instead of clicking on never as one of their options, they just skipped over the question completely. So we had 111 missing pieces of data in those variables for the vegans, the vegetarians. And so I went back through and we had a look and we had a discussion, which is what we always do when something like this happens. The supervisory team and I had a discussion, and we decided that because they were all vegans and vegetarians who had missed these, we just went in and gave them the score for never, because they would not choose that they eat meat 5 times a week, 3 times a week, 1 time a week. They would always choose never. So we went in and force entered never into all of the missing data pieces and then recalculated the total score. So things like this commonly happen because there is always human error in surveys. But it was really cool that we found it because we're actually analysing this data at the moment. And that was something that we had missed. So we fixed that all up and the data set now has 0 missing cases for all of those. Now, if that was the case where we had 111 people missing data, but there was no explanation for why they were missing and they just missed it, we would have had to have made a different decision. Now, most of the time, a decision like that would be to take all the answers from the participant, from all the other questions on that scale, and then average them, and then put the average into those missing boxes. But this time we didn't need to do that. But there's always ways around things when you find something like that. You never have to panic. Okay, so let's have a look at our statistics now for our data set once it's been fixed. So can someone please tell me what the average age of our data set is?
31.96.
Very good, so around 32. Now our standard deviation, which is just below the average, is 7.6. And what that means, and we ran through this last week, but I'll go through it again because standard deviation is quite hard to understand. Standard deviation means that on average, so it's always based on average, the group of people that we have assessed range between, say, 32 minus 8, so what's that, 24, and 39. That's the average range of people, between 24 and 39. But you'll see down the bottom, what are our actual minimum and maximum ages for this data set?
18 and 62.
18 and 62. Now, that's a bit weird if our actual minimum and maximums are 18 and 62 years old. How come then our average range is between 24 and 39? And our histogram will give us a little bit more of an explanation of that when we go and have a look at it in a second. Now our skew is 0.241 and our standard error of skew is 0.145. And before I mentioned that the general rule of skew is that if the skew is any more than 3 times the standard error, then we've kind of got a problem with skew. I tend not to really look at the statistics for skew because they're hard to interpret and understand. I usually just go and have a look at our histogram because it's a much easier way of determining skew. So this is our histogram for age. Who can tell me anything interesting about this histogram? What do you think it's telling us?
It's fairly normal.
It does look normal. However, we have a little bit of an outlier. Can we see the little blue box over behind 60? So we've got someone who's age 62, which is our maximum score, but they're very far away from all the other ages, aren't they? Got a couple of people just under 50, but most of the people in the population fall kind of between 20 and 45. Yeah. And that's why our standard deviation is kind of telling us a little bit that the predominant amount of people, the average amount of people fall in a much smaller range. Happy with that?
Megan?
Yes.
Megan, I have a question, please,
Cool.
and you might be going to cover it. With the marine science that I do, we don't use standard deviation, we use standard error. We're always told that standard error bars and everything. Are you going to talk about that like some other time in the future?
Yes, we cover standard error.
Right. Good.
And standard
Thank you,
error.
I get standard deviation. Standard deviation to me makes sense, but I haven't quite worked out standard error.
So standard error is the same thing, except when we talk about standard deviation, it's the average that the population is around the mean, whereas the standard error is the average of errors around the mean. Now, we'll start talking a little bit more about errors when we do regression next week. And
Great, thank you.
Yeah.
That's okay. No more explanation. I'm following this at the moment. That's great. Thank you.
Great. Okay, cool. Let's go and have a look at BMI. BMI is one of my favorite things in health to look at. Although I'm going to give a disclaimer, BMI is a terrible measurement of health. It tells you who's heavier, in comparison to their height and weight, but it doesn't tell you about health, because there's lots of people who have very thin frames who are not healthy, and there's a lot of people who have heavier frames who are healthy. There's also people who are more muscly tend to fall into the overweight and obese categories when they're quite healthy. So BMI is a terrible measure of health, but we
And there's a
constantly...
62 there.
I
BMI
know.
of 60.
Does anyone know what the BMI cutoffs are? What the healthy range is?
Way below 62.
Yeah, so under 18.5 is underweight. So we've got a few people underweight. Average weight is 18.5 to 25. Overweight's 25 to 30, and then anything over 30 is considered to be obese. So double 30 is a worry. Of course, we can go back and find the person who's got the 62 BMI and see their height and weight and see if we think that that might be an error as well.
Probably a vegan.
Do you think?
Just joking.
I was going to say. Okay, cool. So our average, let's talk about our average BMI.
Sorry, Megan.
Yes?
You would need to go back and check that though, wouldn't you? Because that's so far out, and that would throw all of your, like, yeah.
Let's go have a look. And this is all about why we do these. And we're picking up now the importance of data cleaning and descriptive statistics and asking questions and critically thinking.
And
So-
when people say that qualitative, they don't like qualitative research because it's interpretive. Yeah.
Quantitative is so interpretive, and the decisions that you make whilst doing your analysis shape how the results come out. So you're absolutely right. I'm just going to share the data set again.
But it's subjective interpretation.
Yeah, can be. So our person who has a BMI of 62 is 38 years old. She's a female. She has a height of 165, so that's about me. I'm 165, and she has a weight of 170. So that sounds right. I'm 55 kilos and 165 centimeters, so that sounds right. She is a vegetarian too, Dennis.
Eats a lot of pasta.
Yeah, one of the things that we are finding in this research is that vegetarians can have healthy and unhealthy dietary patterns as well. Like there's a lot of processed vegetarian food products on the market. Cool. So it's good that we're thinking with our critical hats as we go along and do this descriptive.
From that data, almost everyone just on that group has a higher BMI.
Yeah, because I sorted the BMI column descending.
Okay.
So it was going from the highest BMI down.
Okay, thank you.
A good point.
Megan, with a anomaly, so to speak, like that, would you go back to the original, if you have access to the original survey, to just check that she did actually write that? Because I'm thinking it's possible it could have just, she could have just written the wrong number, or someone could have transcribed it incorrectly.
Yeah, we could do that, but I think it might be correct.
Yep, that's fine. I'm just wondering. Yeah.
But this is exactly what Peter and Dennis were saying, is that it's very subjective about what you keep in, what you take out, who you remove, So you have to make some really important decisions about your data set when you're doing your descriptives.
There'd be no reason to take it out, would there?
No. And by taking it out, you could be skewing your data set
Yeah.
or including bias. Yeah. But if you ever do take someone out like that, you must always put it in your write-up when you're writing your results. Say one participant scored a BMI of 100 of 62. This was decided that by looking at her height and weight, this may not have been a correct, or it might have been an error in typing, so we removed the BMI for that person. But you wouldn't remove the person completely. You could just take the BMI out and just not calculate her BMI in any of the analysis that you do. Good detective work, people. Love that. Okay, so let's have a look at the histogram of BMI. Someone want to tell me what it looks like?
Positively skewed.
Say it again, Diana.
I said positively skewed a bit, isn't it?
Yeah, it is positively skewed. That's good because most of the people are falling into that kind of average healthy range, which is normal for BMI. It's usually positively skewed because we do have quite, we always see it looking like this because most people are in that healthier average and tapering up to some people with higher BMIs. Now let's
Megan, for those of us who don't know, can you explain what positively skewed means?
Oh,
please?
good. Thank you for that question. I still have trouble with it. So positively skewed means that the data is all kind of pushed towards the left-hand side of the bar graph, of the histogram, sorry. And
so we're looking at the bars, we're not looking at the curve at the moment.
Yeah, well, the curve also tells you that because the curve is nice and rounded at the left-hand side of the screen and then it like falls away. It has a tail at the back end. Can you see the tail across the, yeah, so that's a positively skewed data set. Normal age kind of looks more normal to me. See how it kind of needs to be a little bit more right over to the right, but it's more normal. But negative skew is the other way. So if we had heaps and heaps of people with like in the obese category and less people in the average category or in the healthy category, our bars would all be up on the right-hand side and the tail would be on the left-hand side.
Megan, could you remind me who these people are?
In what way? How do we collect our data?
Yeah.
Yep. It was all done on Facebook, but we were targeting vegan, vegetarian, vegan and vegetarian Facebook groups. Okay. Also, my kind of network of people in diet and depression shared it over Twitter. Okay,
thanks. So it wasn't just university students?
No.
Thank you.
And that's why age is kind of, we've got more of a higher age average. We've got a 32-year average. Usually with undergrad or university students, we get a much lower age average.
Okay. Thank you.
I've got another question, please. Why do we look at skewness? I can see now, I'm really thrilled because I've never understood how to even tell.
Yeah.
But what do we do with that information? Now I know to look for it.
Okay, that's good. So this is all about our assumptions testing. So before we do any form of statistical analysis, we need to make sure that our data is following some assumptions. One of the assumptions is that our data is normally distributed. And skew tells us that it's not normal. It's either to the left or the right of normal. But normality is not really that much of a problem if you have large sample size. So we've got over 280 people in this sample size. So normality doesn't kind of matter if you've got, say, over 30 or more people in each category. So that's one of the things that we'll have to check, is that we've got more than 30 people in the vegan, vegetarian and omnivore group before we continue to do our data. But we aren't up to splitting the groups yet. But yeah, skew tells us a little bit about normality of the data. Cool. So let's have a look at sleep quality. So our sleep quality variable is what was your sleep quality in the last week? 1 indicates poor sleep quality and 10 indicates good sleep quality. So who can tell me what the mean of the group is in sleep quality?
6.62.
Yeah, so that seems kind of greater than average, just over average. Standard deviation of about 2, so people were scoring between 4.5 and 8.5. Skew's 0.529. Seems a little bit skewed, but that would be just to the healthy range because most people would have good sleep quality, so that's to be expected. So let's have a look at our histogram.
Someone had 1 hour sleep a night?
Yep.
Okay.
They certainly did. No, it's not hours sleep, it's sleep quality.
Oh, I'm sorry.
So we can go back to the variable and see exactly how that was asked.
No.
But so this would be, it's just a measure of sleep quality, but it's kind of normal. I would call that a normal curve. Most people around the middle-ish. A little bit negative, which means that more people had better sleep quality. Okay, let's have a look. Physical activity. Who can tell me what the average... Okay, so this one's hard to understand. So it was measured, how many days in the last month did you do 30 minutes or more exercise? So that's how we measured this. So who could tell me how many days on average everybody did?
13.
Yeah, around 13, but the standard deviation is quite high. It's around 10. So what that means is that there was a much bigger average across the group than what we've seen in age and BMI and things like that. So people were ranging between 3.5 to 23.5 days of doing 30 minutes or more. And physical activity is a funny one because everyone is so different. And this one was in a 31-day month, so I think it was in July. Let's have a look. Here we go. What does that say? It's different, isn't it?
Yeah.
So it's kind of all over the place.
Wow.
Yeah.
Megan, how did you define physical activity?
Yeah, so it was how many days in the last month have you done 30 minutes or more physical activity?
Okay.
And so it would have been any type of physical activity, to be honest.
Okay.
So
But the definition is up for the people to define, is that?
It would have been written into the question.
Okay.
There would have been an example of what we consider to be physically active, but it's very subjective at the moment. So yeah, I could say 30 minutes or more. I go walking each morning, and then someone else could be doing weight training for 30 minutes or more. Someone else could be doing running. So yeah, it's not an amazing measure of physical activity, but enough for us to see who's active, who's not.
We have a large variation.
Mm.
Could we just have a look at the standard deviation again?
It was 9.7.
Okay, so that's very substantially mentioned.
Yeah, so it's a big range,
Yeah.
which is to be expected with physical activity.
Yeah.
All right.
Wow.
The next one is our depression score. That's our dependent variable or our outcome. Scores on our depression scores range between 0 and 60. Higher scores mean you have more depression. And the cutoff, if we're going to dichotomize this, which we haven't, it's a continuous data, but if we were going to cut it off, 16, anything over 16 indicates depressive symptoms. So can you tell me what our mean depression score is?
15.
Good, so it's under our cutoff, which means on average, most people do not have depressive symptoms. This will be interesting when we go to split the groups.
Yeah.
Cool.
Was this taken during COVID time?
It was in July, yes. Very much so, and which is a very important point because that will have to be a major limitation in the paper. Major
And the
limitation.
fact that the standard deviation there is 11 when the mean is 15, is that sort of significant, or not statistically significant, but that looks to me, with my very limited knowledge, like that's quite a big deal.
And that's a really good point, Nicola, because all of these descriptive statistics are just telling us what the data looks like. It's not telling us if that's a significant difference or not. There is no significance testing being done on descriptive statistics.
Yeah, that's what I thought. But
Yeah.
that a standard deviation of 11 when the mean is 15
Huge.
means there's quite a big range, doesn't it?
Yeah. So it means that depression scores range on average between 4 and 26. So let's have a look at the histogram because it'll show us a little bit more about that. There she is. Most people in that healthy range between 0 and 16. But then we've got quite a few people underneath that cutoff. So it might even be worthwhile dichotomizing this into depressed and not depressed. And that would mean that everybody who was kind of above that 16 line would be in one column, in a bar graph, and everyone on the under the 16 would be in another column, and we could look at it that way.
Is it depressive symptoms or depression?
Very good question. And this is a problem that we have in all depression research, is that all of these scales don't actually measure depression. This one is not a clinical measure of depression. It's basically telling us if people are experiencing the symptoms of depression. So that is a very, very good question. And the CESD, the percentage of people with depression normally is around 60%, whereas in the population, it's about 12 for clinically diagnosed depression. So and the reason that I use this in all of my data for my PhD is because I'm really interested in that kind of sub-syndrome or sub-threshold kind of area. I'm not really interested in people with clinical diagnosis. I'm interested in the people who cannot be diagnosed with depression but still have the symptoms, because they're the ones that diet can really help.
Yeah, so you'd have to be really careful then if you did want to break them into groups, not label one as depressed and one as not.
Yeah,
depressed.
so one would be, yeah, it would have to be, yeah, very much so, very much so. Very good. I love these questions. Everybody's like so onto it. All these things that I learned in my PhD a lot later. Social connectedness, my favorite variable when it comes to depression, after diet, of course. So the social connectedness scale was measured, ranges between 8 and 48, with higher scores equaling greater connectedness to others. So what's our mean, our average rate of social connectedness?
35.
Yep. Keeping in mind this was during COVID while we were all locked away. People's social connectedness ratings were still massive. Now, I'm really interested in the relationship between social connectedness and depression at the moment, because COVID can be really affecting that. So once again, we've got quite a high standard deviation, not quite as high as the average. Go and take a look at the histogram. Can you tell me what's happening here?
Very skewed. Negatively skewed.
With my recent knowledge, I can tell you it's, negatively skewed.
It is negatively skewed, but negatively skewed is a good thing, because the higher the score, the better the social connectedness. So we've got quite a lot of people who are scoring very high on social connectedness, which is good.
That's great.
And during COVID.
My depressive symptoms would be higher with more social connectedness.
You're introverted. Okay, so the final two are our plant-based index and our dietary screening tool. And these are important because they're the exact same scale, but with the meat, dairy, fish and eggs reversed for vegans and vegetarians. So looking at these scores on exactly the same scale with the couple of things reversed will tell us quite a bit about the differences between the omnivores and the vegetarians. So who can tell me what the average, the scores range between 0 and 100 with higher scores indicating greater diet quality. Who can tell me on average what the plant-based index score is?
73.
And our dietary screening tool?
64 almost.
Yeah. So diet quality across our group was higher when we reversed those scores, when we reversed the meat, dairy and egg scores, because a predominant amount of people in the population were vegans and vegetarians. So that's very, very important to understand about our group. And we also have to make a decision about whether we're going to use the plant-based index or the dietary screening tool when we do our analysis.
So Megan, just to clarify that, you're saying that your respondents were 8 more plants than the normal population, is that what you're saying?
Yeah, because we had so many vegans and vegetarians compared to omnivores,
Okay.
there was about 3/4 plant-based diet. And it's unfortunate because we only realised that kind of at the end of data collection that we had like 26 omnivores at one stage. I'm like, oh my gosh, we need some normal people to people on a normal dietary pattern to start answering this. And it was the way that we had originally done our social media, can't think of the word for it, like the thing that our advertisement. That's the word. Thanks, Dennis.
Yeah.
Lose normal words, you know.
Recruitment, I think, is the polite word.
Yeah, so when we did that, you have to put it through ethics, obviously, and you have to use the exact wording. And when we did that, we realised that our wording was kind of telling people that it was only for plant-based dietary patterns, and people who did eat meat were like, oh, I don't qualify, I'm excluded. And so we didn't realise that to right at the end. So we had to try and get some more omnivores into our
73 in the plant-based diet is higher than normal people.
Yeah, it's 10 points higher.
Okay.
But we haven't split this between the vegans, the vegetarians, and the omnivores yet. We'll do that in a sec.
Okay.
So this is our plant-based dietary pattern. What do you reckon about that histogram?
It's normal.
It's normal.
Yeah.
It's nice and normal. What about our dietary screening tool?
Almost.
Is that a little bit skewed?
It is a
Or
bit
you'd say it was
negatively
normal?
skewed. And that negative skew comes from the fact that this is the score when meat, dairy, and eggs haven't been reversed. And so all the vegans and vegetarians score 0 for diet quality when we use this tool.
Can you just explain that again? What do you mean reversed?
Okay, so in the questions, in the dietary screening tool is a pre-validated questionnaire on diet quality. And it asks, how many times a week do you eat this type of food in each question? And then it gives the participant a score between 0 and 5 for each food type. And then it rates it on how healthy that food type is. So in the meat, there's one about lamb and beef, there's one about fish, there's one about eggs, there's one about milk. And if you eat them more than 3 times a week, or whatever the Australian Dietary Guidelines say, you score 5 points. But if you don't eat them, then you score 0 points. So when we do the dietary screening tool on the vegans and the vegetarians with those 5 questions, they score 0 for healthy diet because they just don't eat those things. So it's disadvantaging them. So the plant-based index, which is this one here, we've just reversed those scores so they get a 5. All vegans and vegetarians get a 5 for all of the meat, dairy, eggs questions if they say 0.
Megan, I'm just thinking, I think I did this survey.
You probably did.
And just from remembering going through the questions, one of the questions was really specific about the milk and asked either low fat or normal fat or something like that.
Yep.
But again, there's an interpretation there because I know that, like, I don't drink low fat milk. So it was a question that it was a no. So the way that that's then recorded.
Yep.
Yeah, interesting.
And this is one of my pet hates about the dietary screening tool, is that my belief is that full cream milk is actually better for you and to me is considered more healthy, whereas low-fat milk is on the Australian Dietary Guidelines as being the healthier milk. So whenever they ask a dietary screening health quality question, they always say, how often do you have low-fat dairy? And I'm like, it always makes me angry because I consider full-fat dairy to be actually healthier, especially considering how much sugar they pump into low-fat yogurts and things like that.
Yeah, so that would even bias of your results because all of that, fascinating.
And that will be something that I put into
all cans of worms.
Yeah, every time. Yes.
Question.
Mm-hmm.
So if you give the vegans and vegetarians an automatic 5,
for not eating meat, dairy, eggs.
yeah, is that which means they have a high quality diet? Is that correct?
Yes.
Is that legitimate?
That's why we have both of the screening tools. We have both the plant-based index and the dietary screening tool before those were reversed so that we can compare those two and see whether diet quality changes over the vegans, vegetarians when the scores have been reversed. So we would just not create the scale and use it and be like, oh, it's okay, you know.
Okay, so in a way you're controlling for the possibility that vegans getting an automatic 5 may not necessarily indicate a high quality diet.
Absolutely. Absolutely.
Okay, thank you.
Very good. Cool. So there are continuous descriptives. The next thing that we will do is we will look at our categorical descriptives. So this will be, what we've just done is all the data that could be measured on a continuous scale. The next data we're looking at is all the data that is measured in a categorical scale and the descriptives for it. So I will share my screen and we'll go back to the data set. Cool, so once again, analyze, descriptive statistics, exactly the same, frequencies, reset. This time we keep the display frequency tables box clicked, and that will basically give us how many people were in each category. And that's why we don't want to do that for continuous, because there's so many categories, because there's so many points of data. So we want to look at gender, we want to look at marital status, education level. We want to look at our dietary patterns, which is our vegans, omnivores, and our vegetarians. And I think that's it. I think that's all of our categorical data that we are interested in. Oh no, sunlight exposure is down here. We want to look at that too. That's important. Okay. Now we don't want any statistics because it's categorical data, and the best way to look at it is using a bar chart. And we want to look at percentages because they're easier to interpret than frequencies. And then that's it. And so this is our categorical descriptive data. Now, as you can see up the top, our big N says there's 280.
We can't see that.
Oh, every time.
Get your act together, Megan.
All right, so as you can see now, we've got 284 people in each of the categories, so no missing data. So let's have a look at gender. So how many males do we have in our data set?
Not enough. Severely deficient.
We do. How many females do we have?
Too many.
Why is this a problem? Could be a problem. Why could this be a problem?
Well, because there might be something associated with women that, for which you haven't asked the right questions, so to speak.
Yeah, very good.
It could become biased. I think that's the word.
Yeah, it's massively biased. So we are basically only really figuring out the differences between diet and depression in females, because there's only 24 boys.
Yeah.
Another problem with that is that, or it may not actually be a problem, it might actually be something that helps us, is that when we look at depression outcomes in populations, females normally have higher rates. Although, a second disclaimer, I actually believe that maybe it's half-half, but males are just super underreported. Males don't seek help as much as females do for those types of things.
Megan, do you have any ideas on why you got so few males responding?
It's normal, especially in psychological research. It's completely normal to have 90% females.
Why don't they respond?
Men are just not interested in completing surveys compared to women.
Okay. Too hard, maybe.
Also, another thing that could be is that because we predominantly found vegetarians and vegans, more females usually are vegetarian or vegan. That could also be another reason. But these are all things that we need to report in our limitations section.
So there would be a lot of literature on that for you to refer to, correct?
Yeah,
Okay.
there should be, yeah. We'll find it and refer to it. Okay, cool. Then marital status. Tell me how many, remember last week how in marital status we had in a relationship, married, we had like 6 different categories. And I said that I would normally transform them into 2. So partnered and unpartnered. So this is this data set, I've done that. So how many people have a partner?
190.
193.
Yeah. How many are single?
91.
91.
Cool. That's about normal as well. What about our education levels? Once again, I've changed them.
Just,
Yes?
excuse me, just before we leave marital status, how do these figures relate to the normal population in our culture?
Yeah, that's about pretty similar.
Thank you.
Yeah. And as you can see over here, you've got the valid percentage. So it's 68% to 32%. That's about normal.
Okay.
Yep. What about our education levels? Does someone have a question?
You got a highly.
Yes, I do.
Okay.
Going back, Megan,
Mm.
you had transgender. There was only one. So what would you do about that person?
Okay, so our transgender, our non-binary people, I would keep them. I would probably put them into the same category and keep them. Definitely, they're an important part of the population. I don't want to absorb them into something that they're not.
And what about prefer not to answer?
Just leave them. Gender's not a really big part of our research question. It's just an interesting thing. In fact, I don't think gender is significant, so it doesn't end up being put into the model anyway. What about education level? What have we got? High school, university, and trade.
You have a highly educated group.
Not the limitation.
Yeah.
So we're not really accessing information about people of a lower socioeconomic status at all. So we're only really finding out about females who are educated.
Why is that happening, Megan?
Beg your pardon, sorry?
Why is that happening? Why did that happen?
Potentially because people who have vegetarian and vegan diets tend to be more educated.
Okay.
Yeah.
Or frequent where you went looking for.
Yeah. The Facebook groups that we probably targeted were full of more educated people.
I find that a really interesting statistic. Yeah.
Yeah. Yeah. We didn't even hit the staff and students of either of the universities that we worked at, to be honest. So that's interesting.
I'm guessing maybe 1/3 or 40% of people would be university educated in our society.
Yeah. So that's quite high, 80%.
Wow. Yeah. Yeah.
I think there's a difference in how people perceive surveys and research as well. I think people who have moved through university can perceive it quite differently to like a survey that's recruiting people would perceive it quite differently to people that might not have that education. So I think that's why you can also get a
Gamit's also put up an interesting point that because I was the predominant person who put the data out there or the link out there, that my circle's quite educated, and I was promoting it on Twitter through my sources who are in research in diet and depression as well. And then they were sending it out to their sources who were all in the field. So, yeah.
I believe that people who are higher educated and also women tend to respond to surveys more too.
Yep, very good. All good reasons. Excellent. So all important category, our omnivores, vegetarians and vegans. Very important, because remember I said anything for normality to be assumed and for us to be able to do any form of analysis, we must have at least over 30 people in each category. So how many omnivores did we end up with?
64.
Not many. It's about 23%. How many vegetarians do we have?
19%.
And how many vegans do we end up with?
Oh, 60%.
Yeah.
Wow.
And we actually thought when we started recruiting that we were going to have trouble getting vegans.
Wow.
Yeah. Pretty crazy, hey? We were shocked.
What are the implications of these figures for the validity of your study?
There's no problem because they are, well, there is a problem because what we do Anova, the variances between the groups aren't even, but we can do some form of transformation to adjust for that, like Bonferroni or something similar. Gamete. It might be because your circle, oh, you said that already. It is surprising because only 12% of the Australian population is vegetarian. What about vegan, Gurmeet? Do you know those? You should know those.
Gurmeet knows
It would
everything.
be less, wouldn't it? Gurmeet, vegans would be less than 12%, wouldn't it? I assume.
Yeah.
All right, final one, sunlight exposure in our categorical data. So how many days per week, or how many minutes were you in the sun, or hours were you in the sun days per week? And instead of looking at all those crazy numbers and figuring them out, it would be easier to look at the bar chart. Hence the reason we always look at figures. So there's our gender one. It's definitely telling us we have a problem with too many girls.
Good luck.
Marital status, there's our marital status, kind of okay. Education level, problem.
Wow.
Dietary pattern might also be a problem. So this is why descriptive statistics are so important. So important to know what is happening. There's our sunlight exposure. How much easier is that to read than that table?
Yeah.
So lots of people are getting enough vitamin D by lots of things. So people are spending way more than 30 minutes a day in the sun. Maybe too much. Cool.
So basically it's a study of female vegans.
Educated female vegans.
The data is really, yeah.
Yeah, and we'll make a decision when we come to doing our analysis whether or not we will turn it into a study about vegans only and just get rid of the omnivore and vegetarians and only analyse the vegan group and then turn the paper into that.
Isn't it funny how, you know, excuse my French, but in a way you're making it up as you go along.
Yeah.
And you're forced to do that by the data that you actually get.
Yep. And that's normal. So don't ever freak out if your data doesn't do what it's supposed to.
Wow.
There are other options.
So registered reports and things like that, doing it beforehand.
Cross-sectional data doesn't have that because it does change so dramatically. As long as you're not, say we looked at the overall diet and depression, there was no significant relationship, and then we're like, ooh, we don't like that, let's just look at the vegan group, then that's wrong. But if we are looking at the vegan group because our group variance is out and that will change the results or skew the results, then that's okay. But that would all be written up in the report.
Do we talk about, over the weeks, do we talk about p-hacking and what that is, how you do that? Because I would be interested to be able to pick that kind of stuff up, or that's maybe way
it's
too
very
advanced
hard.
for me.
It's almost impossible to p-hacking is when researchers find a non-significant result and they change their analysis to get a significant result. That's what p-hacking is.
Yeah.
It's very common, but it's impossible to pick from the paper because they will just write the paper around the result rather than the other way around.
Megan, I don't want to hear about this.
It's a very real problem.
So Megan, that would be partly why when you submit a paper, you're asked if you'll make your data available. I guess.
Absolutely.
I've wondered about that, having not experienced any of this. I've only just submitted one paper. I thought, well, who cares about my data? Yeah, okay, that makes sense.
Yeah. Cool. So any questions before we move on? We're going to actually look at the relationships between all these variables that we've just had a look at and the outcome, which is depression. And that's the final part of doing a descriptive statistic, when you just got a question about the relationship between variables. Okay. Let me share.
Sorry, Megan, can I just ask? I thought I saw the thing that goes for this, the ad, that it goes for an hour. Is it actually longer?
It's 2
hours.
Ah, why does it say till 10 on something that I looked at? That's why I had to cut off early. Okay, well, I've got another meeting now, but I will book that out longer.
Yeah, there's a recording as well that you can do
Okay.
the last bit and follow
All
along
right.
with the data set.
I'm glad I asked. I'll book that in for the next week. Sorry about that.
Not a problem.
Okay. Bye.
Bye, Peter. So the final thing that we do when we do a descriptive analysis is we look at the relationships between the variables and the outcome and whether or not they're significant. And this will help you build your model. And when I say build a model, I'll stop saying that because it's confusing, but I will just say that this is the final thing that you do to decide which variables you include in your final analysis or in your inferential analysis. So to do that, it's really easy. Analyze, correlate, and correlations are the same thing as relationship. So we're just trying to see a relationship between the outcome and the variables. Bivariate, which is just two variables, we're looking at the relationship between the outcome and each variable. Reset. Now, correlations can only be done on continuous data, which is fine with us because we only are really interested in kind of the continuous data anyway, but we'll always put our outcome variable, which is depression, first, so that the table is easier to read. Outcome first, and then any of our demographics and our confounding variables that we want to see. So we might actually put our independent variables for second and third so we can see what their relationship is. So we'll look at the plant-based index and the dietary screening tool. And then we'll look at our kind of confounding variables. So we think maybe age has a relationship, BMI might have a relationship, sleep quality, physical activity levels might have a relationship, and then finally, social connectedness. Yep. We want to do a Pearson's correlation, just a really quick, simple look at the relationships between two variables, not people. We don't want our means and standard deviations because we already just went and looked at that. So that's, okay. Now, before I share, I'm going to warn you that this will look scary when it comes up and there's lots of numbers, but you only actually need one row of them. Can everyone see that?
Yeah.
This is called a correlation matrix. A correlation matrix basically just tells you the relationship between your variables and whether or not they're significant, which our descriptive statistics did not tell us. It looks like heaps of numbers, but it's basically a matrix of the relationship between every single one. And we're only really interested in the relationship between the outcome and the other variables. So we'll only ever really be looking at that first row. CESD, the depression score, and then the rest. Now the first one is CESD and itself. So the depression variable and itself have a perfect relationship of 1. So a correlation can be measured anywhere between 0 and 1. The closer to 1, the relationship, the stronger the relationship. The closer to 0, the weaker the relationship. So around 5 or 0.5 is considered strong, and about 0.3 is medium. Anything about 0.1 is kind of a weak relationship. Now, the other thing that you need to know about correlations is that they can be negative or positive, and I'll explain the difference in a second when we have the actual data. So let's have a look at depression and the plant-based index. Now, this is the one where we changed the scores around for the vegans and the vegetarians. So our depression correlation between depression and the plant-based index, which is diet quality, is negative 0.10. Now that's kind of a weak correlation. And if you have a look at the p-value, what's the p-value there?
Not significant.
67.
That's right, so it's not significant. So there's no relationship between diet quality in the plant-based index and depression. Interesting. Let's have a look at our dietary screening tool. That was when we didn't change those variables around. What is it telling us? What's its correlation?
0.001.
So it is significant. Interesting. So there's some interesting things already happening, but the correlation is only 0.19. So there's about 0.2, which is still quite weak. So there's not a very strong relationship. Now see the little negative values in front of the diet quality?
Yeah.
So what that means is as diet quality increases, depression decreases. So that's good. At least as diet quality goes up, depression doesn't go up. At least it's in the right direction. But yeah, quite low relationship.
Sorry, could you tell me again which of these numbers indicates significant relationship correlation?
Yep, so the correlation is the first line. So that's the strength and the direction of the relationship. And then the one below it, significant two-tailed.
Okay.
That's whether or not it's significant or not.
Okay.
And then you've got your N underneath, which is how many people are in that.
And 0.001 is significant.
Yeah, it's very significant. 0.05 is significant. 0.001 is quite significant. Much more. That means there's only a 1% chance that we got that wrong.
Okay. Okay.
Okay, let's look at age. What can you tell me about age? What's the correlation between age?
As people get older, they're less likely to be depressed. But
Very
it's only
good.
Yes.
0.2.
Yep, and that is
And it's
backed
significant.
by the literature. So that is a common thing that we see. As people get older, their depression symptoms decrease. And that is significant, very good. But still a bit of a weak relationship. Can you see that? It's only about 0.2. It's not a very strong relationship. Let's look at BMI. That's an interesting one. So what is BMI telling us? What's the correlation between BMI and depression?
The higher your BMI is, the more likely to be depressed.
Very good. So we've got a positive relationship between BMI and depression. The higher your BMI, the more depressed you are. Is that significant?
Yes.
Yes.
Yeah, very good. But still, again, quite a weak relationship, not very strong. Let's look at sleep quality for all of us out there who have trouble sleeping. What is it telling us?
Negative.
Higher. Sorry, go ahead, Dennis.
No, you go ahead. Please.
I was going to say the higher, no, the poorer the sleep, the higher the more, the greater the depression, for want of a better way of saying it, and it's very significant. And
It's the other way around. Yeah.
So better sleep quality equals less depression.
Very good. Yes.
Yeah, that's what I was trying to say. and it's close to 0.5, so
Yeah.
that's quite a strong correlation, and it's 0.000, who knows what the number is after that, so it's quite strong, but quite significant.
It's very significant. So there's less than a 0.01% chance that we got that wrong. And you will always report anything that SPSS spits out at you with 3 zeros, you always report it as less than 0.001. Cool. All right, let's talk about physical activity. What's the correlation between physical activity and depression?
Can you move it onto the screen so we can see it, please?
Oh, is it?
It's just off, yeah.
Oh, it's on my screen. That's
Yeah, no,
interesting.
I can't move it, Dennis.
Dennis, you might need to change your viewing.
I know. I've got the pictures of everyone on the call on the screen. Yeah,
No, it's on.
I've got it. Thank you.
Who wants to tell me what the correlation between physical activity and depression is?
It's negatively correlated.
Yep, so what does that mean?
Means more physical activity, less depression.
Good.
But it's only a 0.145 correlation, so it's not particularly strong, but it is statistically significant.
Excellent. Excellent.
I'm getting there.
Perfectly. Excellent. Okay, finally, social connectedness, my favourite one.
Before we do the last one, Megan,
Yes.
that statement that was just made, but it is statistically significant.
Yep.
So I'm getting the strongest and the weakest, how do we know it's statistically significant again? Sorry.
So underneath the correlation in the significant two-tailed, it's
So the
points.
closer it is to that 0, 0, 0.
It has to be under 0.05 to be
And
significant.
under 0.05. Okay, thank you. I know you've already said that. I'm just trying to get it in my head.
No, that's
I'm
completely
going to
fine.
go and read my quant chapter after this because I've got whole paragraphs that have all of this in it, and I want to go and check my own write-up now.
Perfect. Okay,
Megan,
so
that's about the only thing I really get is that 0.05 business. The rest of it is all brand new. That's why I'm happy to say it, but the rest of it I'm guessing, or not guessing, I'm learning.
you're doing very well.
Megan, it doesn't always have to be 0.05 either, does it? Is that correct? You
That's
set the
the
significance
general-
at the begining.
That's the general rule. Sometimes, sometimes we will use a 0.001 significance and be more strict on our data, but 0.05 is relatively what we use. But there is an argument about the dichotomy of that, because a p-value of 0.049 would be considered significant, but a p-value of 0.051 is not. But there's not much difference between those two significance values.
That's right.
Yeah.
Megan, the asterisks in the line of Pearson correlation indicate the statistical significance. Correct?
Always, yes. So
Okay.
two stars means it's significant at the 0.05 level, and 1 star means it's significant at the 0.01
Okay.
level, I think. No, that's not right. 2 stars is the 0.01 level, and 1 star is the 0.05 level, I think.
So social connectedness is off the charts almost.
Yeah, so let's talk about that.
Wow.
So tell me about what the relationship is between social connectedness and depression.
Let's let someone else have a shot at it.
Okay.
Yeah.
Anyone else want to have a try?
Can you say that again, please?
What's the relationship between social connectedness and depression?
Very strong relationship,
Yep.
because it's 0.7. The more connected you feel socially, the less likely you are to be depressed.
Very good.
And it's 0.000 again, which tells us it's very statistically significant.
Excellent job. Excellent job.
That's really interesting, isn't it?
Yeah. So one of the interesting things about this is that the only thing that came out not significant was our plant-based dietary index, which is our independent variable. Oh no, but that's okay, because that's not our question. Our question in this paper is not what is the relationship between diet and depression in the whole population. Our question is what is the differences between vegans, vegetarians and omnivores. So it's okay that that is not significant across the population. We need to see whether it is significantly different across the groups. Cool. Any questions before we move on to the next stage?
Well, that social connectedness is really
Amazing, hey? It's funny, in my PhD, like in diet and depression research, social connectedness is often not considered, but one of the things that came out of my focus groups, or the most important thing that came out of my focus group, was social context of how we eat. So very interesting.
What does that mean?
So it means like people's mental health and mood are heightened by the context in which they eat. So if you're eating with your family and you're enjoying food together with people rather than eating solitarily on your own,
Okay.
which is also a common pattern in the Mediterranean dietary pattern, which is, yeah, very interesting indeed.
That's interesting.
I don't want to give away too much of my findings of my PhD just yet.
I have a question.
Yes, Gloria.
That you don't look at the correlation between the different variables, but in case they would be strongly correlated, shouldn't we know this so we can decide on one kind of?
Yeah, that's a really good point, and something that we normally do, but I didn't want to confuse everyone. But if you look at the relationships between the variables that are not the outcome so all the other variables and each other, and make sure they're kind of not over 0.8 or 0.9, which means that they're measuring the same thing and that you should exclude one of the variables. In this data set, that isn't the case for any of the variables. They're all under that 0.8.
Okay, great.
That is a good point. If you've got variables that are too closely related to each other, then you've got a problem as well.
Thanks.
Very good, Gloria. Thank you. All right, so that was stage 1. Stage 2, we're just going to have a look quickly in the last 40 minutes, what to do if you are looking, if you're not just looking at the relationships between two variables, but you're looking at splitting it across groups. And this is descriptive statistics as well. It's not going into the inferential analysis too much, but it is going to tell us whether or not the differences between the groups are significant or not, and which ones that we can put into our inferential analysis at the end. So when we looked at our continuous frequencies, everything but our IV was significant, so they could be included in the final analysis. Now we're going to have a look between groups. So the first thing that we're going to do is we're going to look at our continuous variables between vegetarians, vegans, and omnivores. So we go to do that, we need to look at the differences in the means. So we need to compare the mean difference between the groups. So all those means that we got between dietary patterns and depression, and whether or not they're significantly different, the averages between each of the groups. So to do that, we go compare means, and we just want to run a really simple one-way ANOVA. And an ANOVA is basically just a statistical test that we use to compare averages between groups if there's more than 2 groups. T-tests are used for 2 groups, ANOVAs are used for more than 2 groups. So we want to put all of our continuous variables in. So age was significant, BMI was significant, everything was except for PBI. What else we got? Sleep quality, physical activity. Yeah, CESD, I probably should have put that in first, but anyway. Our depression variable, and then social connectedness, wherever he is, here it is. And then our 2 dietary patterns. Plant-based dietary pattern and our normal dietary pattern. And then we want to split it between our groups. So we go and find what our grouping variable is, dietary patterns. And then we just want to go to options and make sure that all of our descriptives are run. And our means plot, because that'll give us a kind of a figure like our bar graphs and our histograms. It's always really important to look at something that gives you a visual inspection of your data, because it's really hard sometimes just to look at the figures and figure them out. The visuals are always so much easier. So we'll run that, and then I'll share the outcome. Output screen. Great. So here are our descriptive statistics between groups. So if we remember before, our mean age across the population was about 32. Our omnivores, the average age is about 34, vegetarians about 33, and our vegans about 30. And then once again, in our totals, we've got our 32 there. So total is the total population, not split. So they're quite similar. Now, when we run our one-way ANOVA, that will tell us if that's a significant difference. So who can tell me here? So this is age here, and then our significance value is all the way over here, and that's all we need to look at, whether those averages between age are significantly different. Who can tell me whether they are or not?
Yes, they are.
They are. Excellent. So age is a significant variable when it comes to our descriptives. So there's a significant difference between the ages between omnivores, vegetarians, and vegans. Let's look at BMI. So our total BMI was about 25, which was kind of a bit above average. So that is in the obese category. I think it's 18.5 to 24.9 is healthy range BMI. So our omnivores are 26. Our vegetarians are around 27. So they have a higher BMI on average than omnivores. And our vegans are at 24. So vegans have a lower BMI on average than our omnivores and our vegetarians. However, do we know if that's a significant difference or not? So let's go down to BMI. Who can tell me whether or not BMI is significant, whether the vegans are have a significantly lower BMI than omnivores and vegetarians?
Yes.
Yeah.
They do. Excellent. So now you can see why descriptive statistics are so important. It's giving you a real picture, a real story about what your data is doing before you even think about analysing your data. Okay, let's look at sleep quality. So sleep quality is between 1 and 10. Okay, so our average sleep quality was 6.6 across the population. Omnivores were at 6.5, vegetarians were at 6.2, and vegans were at 6.7. So once again, vegans have a higher sleep quality than the other two. But is that significant? Is that a significant difference? Who could tell me whether sleep quality is significant or not?
No.
Good. Good. So there may be differences between vegetarians, vegans, and omnivores, but it's not statistically significant. So when I am considering whether or not to use sleep quality in my inferential analysis, I would exclude it now because there's no significant difference between the groups. So it would not be something that I would use in my inferential analysis. And it's a covariate that I'm not going to adjust for because I already know it doesn't really have an effect. Okay, physical activity, let's have a look. So the average physical activity levels, I think it was 13 days per month. Omnivores do about 11, vegetarians do about 14, and vegans do about 14. So vegetarians and vegans have a very similar average amount of days that they exercise, and they are higher than omnivores, but are they statistically higher? What do you reckon about that?
Nope, not statistically significant.
Okay, so at this stage, I would then start excluding physical activity from my later analysis. So it wouldn't be a confounding variable that I would adjust for.
And Megan, do you write all of this sort of thing in your, when you write up the results, do you say that you found these weren't significant, therefore they were excluded, or do you just not report?
It depends on whether you're writing it for a thesis or whether you're writing it for a journal paper.
Yeah, okay. So for a thesis, you would include all that. That's cool. That's what I'm trying to work out at the moment. I'm at that sort of stage once I understand my analysis. Yeah, okay, great. Thank you.
For a thesis,
for a paper,
for a thesis, you write everything. For a journal article, they probably don't need to know as much detail.
Yep, great.
Megan, for a normal person, to start to use SPSS is terrifying, but boy, it's useful, isn't it?
Yeah. And it doesn't take that long to learn. It's because it's like you just have to click and point. Whereas Stata, which I've taught myself during my PhD, you have to learn computer coding. And you have to know the code for each analysis, and it's terrifying.
Which one is that?
Stata?
I don't know that. Okay.
Yeah, don't learn it.
Okay.
Okay, let's look at our depression score. So I should have put that first, but I didn't. So our average depression score was 11, keeping in mind that, no, that's not right. I was going to say it was around 15, wasn't it? Our average depression score was 15, keeping in mind that the cutoff was 16, with people over 16 kind of being more depressed. So omnivores, they had an average depression score of 11.
Oh, wow.
Vegetarians had 19 and vegans had 15.
Wow.
Now, this is commonly seen in the literature. Vegetarians and vegans commonly have higher depression rates than omnivores. Can anyone tell me why that might be?
I don't know, but I'd like to know.
Anyone got any idea?
Yeah.
Gurmeet, do you want to tell us what you think?
Is it the other way around? Would it be that people, I'm just guessing here, some people maybe choose to be vegetarians or vegans because they have an underlying problem that's causing depression, and they wonder if changing their diet might help?
That's a possibility. Can anyone else tell me another one?
I wonder if the vegetarians and vegans are warriors and the omnivores couldn't care. They don't care about health in general.
That's what we think. So we think that they have higher depression rates because they care more about things that are external to themselves.
Wow.
Omnivores do. But we've actually found in other data that vegetarian and vegan plant-based dietary patterns are actually protective against depression symptoms. So there's kind of this U-shaped curve. They have higher depression, but their diet's actually helping them with depression. So it's very interesting. And hence why we're doing this data.
Okay.
That's what this whole data set came out from, was because of that question.
Okay.
Cool, let's go have a look at the significance level. Is the differences between those omnivores and vegetarian depression rates significant?
Yes.
Very much so.
Yeah.
So omnivores are far less depressed than vegans and vegetarians.
Wow.
And that's in line with the other literature as well. Cool, social connectedness. Let's have a look. So our average was about 36, which is quite high because it was 48 was our highest. Omnivores had 39, so they were more connected than vegetarians and vegans, who had 33 and 35. Let's see if that's significant. What do you reckon about that?
Yes.
Why do we think that omnivores might be more socially connected than vegetarians and vegans? That actually just seems counterintuitive to me.
I like barbecues.
Yeah, but they haven't been able to have their barbecue during this period here. Yeah, that's interesting, isn't it?
I would assume vegetarians and vegans would be more socially connected because they are together in one belief system. I don't know. It's interesting when your assumptions don't get proven.
Maybe, if the omnivores are less depressed, maybe they just worry about life in general and less.
Yeah, maybe.
They could, might they be extroverts more? Or?
Maybe the social connectedness thing is because I don't know, when you're a vegetarian and a vegan, maybe you get socially excluded more.
Yeah.
Because people are like, oh, you're vegetarian, vegan, they don't understand their plant-based diet.
Yeah.
I was going to say that too, because it is difficult sometimes catering functions for so many different dietary requirements. So yeah, maybe they just get a little bit excluded that way, or choose to be excluded because they think, oh, that particular function I won't be catered for.
My 7-year-old came home from school last Tuesday and decided he was a vegetarian and has stuck to his guns since.
I wonder where he got that.
Too much food talk in the house.
Well, just out of the blue last week.
Yep. But then we went to a barbecue on the weekend, and his best friend's parents told us that his best friend also went home and said he was a vegetarian.
And this is your son, right?
Yeah, 7.
And has he applied for the PhD program at Southern Cross yet, or? No. But his reason was because he cares about animals, and he said to me exactly this: I wouldn't like it if an animal came up to me and decided to eat me, so I've decided not to eat an animal. Wow.
Yeah, I'm pretty proud of him.
Wow. Mm.
All right, so let's have a look at this plant-based index. So obviously we are going to expect the omnivores not to do very well on this plant-based index because they're getting 0s for all the meat, dairy, eggs, and fish that they eat instead of 5s. Yeah, so we would expect the vegans and vegetarians to do better, which is true. So vegans got 77 on the plant-based index, whereas the vegetarians got 72 and the omnivores got 63. That's to be expected. However, we should see the reverse in the dietary screening tool because those were reversed. So the omnivores should do better, should have better dietary screening, diet quality in the dietary screening tool than the vegetarians and vegans. But what does it actually say?
They don't.
They don't. So even when we don't reverse the fish, eggs, dairy, and meat, the omnivores still have a worse diet quality than the vegetarians and the vegans.
Sorry, Megan, is the dietary screening tool based on the government recommendations?
Yep. The Australian Dietary Guidelines. It's the pre-validated diet quality tool for Australia.
Okay.
So
we didn't need to mess about and reverse score all those meat, fish, dairy, and eggs, because the vegetarians and the vegans still came out with a higher diet quality than the omnivores. But was that significant?
Yes,
Tell me.
it is, yeah.
It is on the plant-based, but it's not in the dietary screening tool. So we've got some unusual things happening. And it's the reverse of what we found before. When we looked at the whole population, the plant-based index was not significant and the dietary screening tool was. But now that we've split it between groups, the plant-based index is significant and the dietary screening tool is not. We have a problem with our data. So that's going to have to be discussed in the meeting, and what's happening there with my supervisor, who would know a little bit more about what's happening. Interesting what your data does to you.
Are you working with Alison also?
This data set, no, this is a data set I'm using with people at Central Queensland University.
Okay.
But yes, Alison is helping me with my PhD.
Okay.
Cool. These are the means plots. This just gives us an idea of what the averages look like. And you basically, omnivores are around 35, vegetarians around 32, with our vegans around 30. So it just gives you a visual idea of what each of the differences between the averages are. So when you look at that plant-based index, is that plant-based? No, that's the dietary screening tool. Yeah, it's so weird that the omnivores came out with lesser dietary quality than the vegetarians and vegans, despite the fact that we didn't reverse code them. Very interesting.
You know, maybe the vegetarians and vegans just put a lot more thought into what they eat.
Maybe. They've got better diet quality because, I don't know, it's called crowding out. When you don't eat meat, you obviously have to replace the meat with something, and you're replacing them with fruit and veg, and fruit and veg are obviously very healthy for you. So that's why I think diet quality is higher, because you're just eating more plant-based foods and less proteins, meat-based proteins. Okay, let's do our final analysis, and then we'll be done for descriptive statistics. So this time we're just going to do the same thing across the three groups, but our categorical data instead of our continuous data. And we only have a very few categorical data that we're interested in. But this time we have to do cross tabulations, which is a chi-squared. So that's in descriptive statistics. And this just gives us the frequencies of each of the variables across each group. So the first thing we want to do is we want to put dietary patterns in rows. So we have our vegans, our vegetarians, and our omnivores in the rows. And then we want to look at marital status, education level, maybe health in compared to other, where did that go? There it is. Health compared to other, that's it. Oh, sunlight exposure, I nearly forgot it again. And I think that's it. And then maybe some bar charts. Okay. So this is our cross tabulations. So I'll help you with this one. So our first one is omnivores, vegetarians and vegans, and marital status. So you can see that our rows are our omnivores, vegetarians and vegans, and our columns are partnered and unpartnered. So we've kind of got 64 omnivores in total. 44 of those are partnered, 20 are unpartnered. 34 vegetarians are partnered and 21 are unpartnered. 115 vegans were partnered and 50 were unpartnered. And the bar chart gives you a little bit of a look-see at what that looks like. I'm just going to go back quickly because I forgot to ask for the significant levels. So if you make a mistake, it's real easy because SPSS has remembered what you did last, so we don't have to do it all again. I just have to make sure I go into statistics and ask for our chi-squared statistic. And that'll tell us if the relationships or the differences are significant. Okay. So, marital status. Who can tell me here? So this is our chi-squared test. We never really have to look at anything apart from the significance level, which is this one here. Is the differences between omnivores, vegetarians and vegans in marital status significant?
No.
No.
No, so I would exclude that from my analysis. Cool.
Does that also mean you don't have to worry about it when you're thinking about other things?
Yep, absolutely.
Yeah.
So
as opposed to that you need to consider the fact that you've got mostly women, that is something you'd have to think about. This one is nothing to worry about.
Did we look at gender? Why didn't I put gender in? Go back. Where did gender go? Why did that disappear? Oh, this one, please. Yeah, because gender is a really important one, isn't it? Oh yeah, I just forgot it. Okay, try again. Cool. Let's go down and look at gender because that was a very interesting one. Where are you? Here we go. All right, gender. So, omnivores, we had 11 males and 51 females. Vegetarians, we had 4 males and 51 females, and vegans, we had 9 and 152. So it's very, very skewed. Are those differences significant?
Whoa, no.
Nope.
0.09 is bigger than 0.05. That's interesting.
And for the very fact that the levels are so, the variance between the levels is so different, and it's not significant, we just would not include gender in our analysis.
Megan, how could that not be significant? I mean,
Yeah, thank you for that question. I'm trying to get that too, yeah.
9 versus 152.
Yeah, so there's no, that's probably the reason why there's no significance, because there's just way too many females. And there's not enough data on males for it to be significant.
Okay, so there's not enough data on males to determine whether there's a
I would say so.
correlation between dietary pattern and gender. Is that what you're saying?
No, this is not correlation. This is cross tabulations.
Oh, okay.
So this is just the frequencies of people in each group. Correlations was what we did before.
I'm sorry. So there's not enough data on males really to give us a meaningful outcome of this. Is that what you're saying?
I would say so, yeah.
Okay.
All right, let's have a look at, so marital status wasn't significant. Let's look at education. So we've got, probably the same thing will happen here because there's so many university educated people. So what's our significance level for high school, university and trade across the 3 dietary patterns?
Not significant.
Not significant. So we would exclude education level from our analysis as well.
So Megan, is this something you're going to have to discuss with your supervisor, what this means? And
no, it's just a really good way of trimming down what your analysis is going to look like, because when you start putting too many variables into your inferential analysis, you'll start getting significant values just because there's so many variables. So it's a good thing to be excluding things and only looking at the things that are significant. So our model would look like depression as the outcome, dietary pattern as the factor group or the grouping variable, and then our significant values, which was the plant-based index, which is our independent variable, BMI, age.
Okay.
Physical activity wasn't. Social connectedness, definitely. Sunlight exposure, I think, maybe. Just the ones that were significant. And then that means that our model is only testing the things that have a relationship between or a difference in the 3 groups, which is what our question is.
So your model of your statistical analysis is really the contents of the analysis, what you include in your analysis. Is that correct?
That's exactly right.
Okay, I finally got there. Thank you.
Great. Can you show that again, Dennis, please?
Oh, probably Megan, because it's just when I've been trying to figure out exactly what Megan referred to when she was talking about her model of statistical analysis.
Yeah, me too.
Means the content.
It's just the variables that are included.
Yeah, what's in there, what she does, and outside of the model is what she decides to not do. So it's as if you've got a box.
Yep. Your model's just the variables that you include in your final analyses.
Okay, thank you.
And then all of these ones that are coming out non-significant are your excluded variables. And as Nicola said, in a thesis, you would write up these ones that you didn't include. But in a journal article, you probably wouldn't need to. It's not necessary.
So Megan, given the male-female distribution in your data, would you consider just making this a study of females?
No.
Okay.
No, because like gender's not significant, so it's not even a thing.
Okay.
It would definitely be part of our limitations section that the data set was predominantly female educated. That's a limitation because we can't generalize our findings to lower socioeconomic status or to more of a male population.
Okay, that makes sense. Thanks. Thank you.
Megan, can I just ask, so we're just saying gender's not significant, but if we had more males, maybe it could be, could have been.
Maybe.
Should we be not ruling that out? Do you know what I mean?
Yeah, one of the things that we probably should have done is when we were data collecting, going into Qualtrics and just seeing how many males we were getting and potentially targeting our recruitment to more men.
Yeah.
But this is a project from an honours student, so
okay,
it's a very good, a very, very good honours project, to be honest.
Yep.
Yeah, the student was amazing. But yeah, little things like that you would normally pick up on that wasn't picked up on, but just mentioning it in the limitations is fine.
Okay, thanks.
Or we could exclude the males completely and turn the journal article into female focused so that we were accepting and being upfront about the fact that we were only looking at a female population. Yep.
Interesting, huh?
Yep. So health compared to peers of your own age is also not significant. So that's one of the ones we would exclude. What about sunlight exposure? Let's have a look at it. Also not significant. So all these categorical variables are not worth putting into the model, basically. So which makes it easier because that means only our continuous data are in the model, which means that regression, we could use a regression, which is only continuous data, which is what we're going to do next week. Right, we did it. Any questions?
Pretty interesting.
Yes, we are. Oh, what we are supposed to be doing a tutorial next week, Gurmeet. We'll be in Ballina. I'll still be doing it. Yeah, I'd say so. Yes, the SCPA has a planning day in Ballina, but it doesn't start till 12, does it? So yeah, I'll still be able to do the tutorial.
Megan, just to start the ball rolling here, I found this really interesting because I did my own statistics with Alison and just did that from scratch, and it took me months. And to go through a different set of data with a little bit of knowledge and experience now, not much, but to go through a different set of data in this way, it's really helping me a lot.
Oh, that's great. I'm glad. Like I said last week, I tried to go step by step through exactly what you will experience from the time you get your data into the program until you go to analysis, whereas a lot of tutorials normally just start at the analysis. And I'm like, what about all the things that you have to do before you do the analysis? Like, yeah. So I think that's important. Next week, we will start by doing assumptions testing and talking about what assumptions are and why they're important and what needs to be done before. So things like normality, linearity, things like that, but we'll have a big discussion about those. And then we will run a regression, which is something that is a statistical analysis you do on your continuous variables. Considering most of our categorical variables got eliminated today, we'll talk about regression and doing an analysis on continuous. And then the week after that, we will do a vote and everybody can tell me what analysis they would like to end the tutorials on in week 4. Any more questions or anything to say?
Yes, you just created my depression.
I think you've
I had no idea how to start, and I was on my own. So, you know, it's very, very difficult. And mine doesn't come out significant at all.
So none of your stuff comes out significant? Is that what you just said?
Yeah, really none of it. And the reason too, because I've got 3 in a data set, and therefore if I do get it near the significance, I've got to go to 0.017, and that's very hard to get. Because that's what I was told to do at one stage. It's Bonferroni or whatever something said.
Oh, yeah, because your variances aren't equal.
No,
So,
like,
that's your...
I might have 3 things on it. I just can't think now because I'm just blown away that it's just a mess. What I've got is a mess. And it's heartbreaking to say that I've spent so much time in it, not knowing what I'm doing, not having anyone to guide me. So, you know, I think I'll go out today and have afternoon tea by myself or something because it has made me very depressed.
What the tutorial has?
Just knowing all that what I should have done beforehand, you know, to do something with the data.
But there's light at the end of the tunnel now, you know.
Okay.
I feel happy. I had a pretty tough time too with my stats, but I feel I had some guidance, but I feel now, you know, Megan's really putting this together in a step 1, step 2, step 3 way, which helps me a lot because I can start to, you know, get hold of it. And,
well,
you know,
I'm at the end of doing it. That's the trouble. And, and I'm really short of time because I'm going to run over time anyway.
Yeah, I did too.
But not having anyone sort of to help, only, you know, I've had a couple of times that I've gone for help, but, you know, there's been nothing like the help that I needed to do that. And my knowledge is from 30 years ago.
Yeah, don't worry, I feel the same thing. That's what the PhD is all about, feeling like you have no idea what is happening at any time.
Megan, I've also, sorry, I didn't want to change it.
Okay.
I also want to say I've been very interested in seeing how your research, the structure of your research and your methodology, or has been, not your methodology, the course you're following is being altered by force by the data you've gathered.
Yep.
Maybe you're not going to end up where you thought you would when you started.
No, and I'm doing mixed methods research, so in my PhD, so I started with like kind of a review of the literature, and then from that I did focus groups, and then my focus groups came out with so much stuff that I wasn't expecting. And then what I did from that was I took variables that have never been measured in diet and depression before and then measured them in a quantitative way across a longitudinal study. So yeah, the way that my PhD is finishing was not how I was expecting it to.
Wow.
Yeah. And it's less about, I thought it was going to be about what foods are the best for mental health, but it actually isn't coming out to be like that. It's more about the relationships between dietary patterns and social context and bio-individuality, that everybody's different. So blanket guidelines for food is not helpful, things like that. And I just did not expect that to be where I ended up at all. So
this is a much deeper study now.
Yes, hopefully.
Yeah, it is. So are you saying because people have biological individuality, one set of issued guidelines mightn't work all that well?
Oh, absolutely. Like the Australian Dietary Guidelines say 2 fruit, 5 veg, 6 whole grains. Like there's no way on earth I can eat 6 serves of grain in a day. No way.
Yeah.
So that in itself, whereas then a man who's 110 kilos and who works out and does weight training and is muscly, like 2 serves of fruit and 5 serves of vegetables is not enough. Or the amount of meat that they tell us to eat per day is not enough, like for someone like that. So bio-individuality is very important, especially when it comes to mental health. One type of food, people who have insensitivities to food will get mental health symptoms from eating foods that a normal person will actually be a healthy diet. So yeah, it's very, there's a lot of things going on.
Well, your research might be an important part of that. That's very interesting.
And the guidelines are so outdated anyway. And people's dietary needs are changing, and it just needs to come to the party with that, I think. Yeah. And food sensitivity, as you said, is just everywhere. So yeah, recommending so much fruit for someone that's fructose intolerant, which is becoming more common now too, is a problem.
There's also like a real U-shaped relationship between depression and meat consumption. So if you eat, say, meat twice a week, then you have lower rates of mental health issues. But if you eat, it's like in the middle. So if you eat low amounts of meat, you have higher depression. If you eat high amounts of meat, you have high depression. But if you eat like in the average middle, like about 3 pieces of meat a week or 3 serves of meat a week, then you have lower levels of depression, if you know what I mean.
Yeah.
So low amounts of meat and high amounts of meat mean more depression. Average amount of meat per week is the best amount. So it's so weird.
Yeah.
All right, I have another meeting.
Great. Thank you, Megan.
Thanks so much.
Very much,
See you
Megan.
next week.
I've got my quant chapter up and I'm looking at my own stats with fresh eyes.
Thank you.
Excellent. And me and Katie will send out the recording and the data set.
Thank you so much. We'll see you next week.
Bye.